some special kinds of treatment processes, one of which is bioremediation. Although bioremediation is more applicable for soil treatment, you can also utilize bioremediation in wastewater. Now, bioremediation utilizes microbes to detoxify or degrade pollutants, and this is also used to enhance some nitrogen and phosphorus content to the soil, or to the sludge for that matter, and can be utilized as a fertilizer. Water and wastewater treatment also utilizes bioaugmentation. This is actually in addition of specific microbes to degrade the pollutant. For example, you can have a series of aeration tanks. So let's say aeration 1 tank, aeration tank 2, aeration tank 3. We normally utilize this when I was in a sewerage treatment plant, wherein the aeration tank 1 would be injected with an enzyme. So the purpose is to make sure that the bacteria in the wastewater would really live, or would live longer. So the strain would be multiplied by the enzyme, because we know enzyme is what? A biological catalyst. So that process is called bioaugmentation. This composing is more applicable to solid waste. Now, bioremediation is normally being utilized for water treatment as well as solid waste treatment for recalcitrant contaminants. Recalcitrant contaminants, known as xenobiotics, are those which are persistent pollutants, cannot be easily degraded with a normal process. So therefore, in order to do that, you have to have appropriate bacteria to be utilized. Remediation. But instead of utilizing microbes, you may use plants. Now, normally there are known to be 350 plant species that can uptake toxic materials, such as sunflowers and water hyacinths. Now, the reason why these plants can be used for the phytoremediation is due to their long extended roots, which are normally utilized to absorb these pollutants. In terms of water pollutants, there are two kinds. You have the point source and then the non-point source pollutants. I have here in the slide characteristics of non-point sources. Now, to summarize this characterization of non-point sources, we have this project together with NSTP, wherein I was asked to have this proposal on how to do a profiling of contaminants present in the Pandacan Estero. So for example, just to define to you what are non-point source and the point source pollutants. For example, you have establishment A, you have here establishment B surrounding the Pandacan Estero, wherein your establishment A, let's say, is a junk shop, while your establishment B, let's say, is a sari-sari store. Then, let's say you have additional establishment C, which is actually a car wash shop. And then D would represent some residential houses. Then, in order for you to determine the profiling of contaminants, let's say you have here sampling point 1, sampling point 2, then sampling point 3. Okay? Now, if you have found that sampling point A would be containing lead, which do you think would be the source of the pollutant? Definitely, you would say it's the junk shop, because the junk shop would involve some heavy metals which are probably run off with water so that it had contaminated the water with lead. Since you can identify the source of this contaminant, this contaminant is classified as a point source. So in the same manner, if you find that this is rich, this 0.3 sampling would be rich in N or P, or let's say P, that would be explained through this point source, because the car wash would be utilizing detergents that would contain phosphates that would run off to the Pandacan estero. So there is no problem with point source pollutants because you can identify the source of pollutants. However, non-point source pollutants would generally cannot be identified. The source could no longer be identified because of the distance being traveled already by the wastewater stream. For example, Laguna Lake. Laguna Lake is already too far from the different industrial establishments that have discharged their wastewater. Therefore, it's difficult to determine who will be or which will be the culprit of a particular contaminant. For this reason, in order to maintain the water quality of a certain river or a certain lake, most establishments are actually coming together into an eco park. You recall? Eco parks they have a common area or centralized wastewater treatment wherein they only discharge to one point. And therefore, prior to the discharge, the centralized wastewater treatment could already identify, since you know who are the locators, what would be the point source of the pollutants. We need to know the sustainable water usage. That is to maintain the water resources that we utilize, especially in order for us to have the industrial plants to be running continuously. So there are some characteristics or criteria for water use sustainability, and here are as follows. Now, the major problem in the industry now is the condition of water resources. There are two conditions of the water resources that we are a fear of. One would be water scarcity and then the water stress. Water scarcity is when an annual water supplies drop below 1,000 cubic meter per person. And water stress is when annual water supplies drop below 1,700 cubic meter per person. This is where the problem comes, especially with the Philippine setting. We already rank second to the lowest among Southeast Asian countries with fresh water availability. That is, we're already nearing water scarcity condition because it has been estimated that 1.907 cubic meter of fresh water would be available to each person each year. This is based from the JICA Master Plan on Water Resource Management in the Philippines sometime in 2007. And globally, this is the situation. So we are already having a 20 liter per capita day from a source within 1 kilometer of the user's dwelling. This would give us the current condition of nearly 2 billion people suffering from severe water stress. And based from their study, by 2025, additional 1 billion people are expected to face water scarcity, 20% of which is due to the climate change. So, what do we need to do? Or what is the industry doing? Or what are the government agencies locally, regionally, and globally doing? So, we want to attain the Millennium Goals that we have sufficient water resources. Now, as engineers, the current trend now is to have alternative water resources. Now, one of the possible water resources that we have would be recycling water from STP. You can do this because recycling would also entail additional treatment. That is just to add some water resources. Now, this is already being done in Ayala, Alabang, where we utilize 3,000 cubic meter of water, not for potable water, but only for watering the plants in a particular golf course. Because in Ayala, Alabang, we have this golf course which utilizes 3,000 cubic meter of the treated effluent from STP. Now, another trend would be what they call rainwater harvesting. So this is actually being utilized in developed countries. They have this vertical treatment, so it's on top, it starts on top of the roofs. So it trickles down, the treatment trickles down from the roof down to the faucets. So they can already utilize this. Now both of these sources, because of the concern on health, again, let me reiterate, would only produce gray water. So what's gray water? So gray water refers to recycled water or treated water. So in Ayala, Alabang, we dream of doing this. So if you have the water pipe here, then you have the wastewater pipeline, then we will have the gray water as the third pipeline. That is, the water will be provided by the water concessionaire such as Maynilad or Manila Water, and then these will be collected in the sewerage so as to go to the STP. The STP will now treat the water and then will bring back as a gray water to the consumer. So you notice this involves an optimal cycle loop. That is to address the problem on water scarcity and eventually having water stress. Now, as engineers, you can also apply your LCA or life cycle assessment in doing this. I have actually done this to compute for water stress indicators. So what are water stress indicators? They measure the proportion of water withdrawal with respect to the total renewable resources. And then here, we depend the water stress on the variability of the resources. So in my case, in my LCA study, I have identified the different water sources, namely the surface water, the groundwater, the recycled water, and then the possible rainwater harvesting. Then the water stress indicators would also need to identify the causes of deterioration of freshwater resources, not only in terms of quantity, but also in terms of quality. So I have characterized the different water quality parameters for each of these sources of water.